Hello everyone. We are now going to continue our second part of the first unit, in which we are going to be looking into the different types of sensors that are available. Before we look into the capacitive and resistor type of sensors of our first topic. So, what is a proximity sensor? It is also called as the IR sensor. IR stands for infrared. Okay. So proximity sensor is a non-contact type. Okay, you don't have to touch it to identify that some object is available. It's a non-contact type of sensor that detects the presence of an object. Touching is not required over here, depend upon the heat generated, that is infrared generated. It will be able to identify and tell that there is an object available. You have seen it in your day-to-day lives. We will see where you have seen it in your day-to-day life with an example in the coming slides. Proximity sensors can be implemented using different techniques, and there are different techniques in which you can detect an object. It depends on the application. So it could be like optical based, that is infrared or laser, sending a light signal, and when that light signal is being detected somewhere, it is breaking up somewhere. What will happen? Okay, an object is there. Sound signal can be generated from here, magnetic type or the capacitive type. So magnetic, you have a separate hall effect sensor that is available over there, but this is based on that particular concept or the capacitive type. And applications, where do you use these? The most common application is the one that you use in your mobile phone. You are using it in your day-to-day life, in your with your mobile phone. You may be aware that when you keep your phone next to your ear, your display automatically goes off. How is it done? With the help of the sensor. We'll be looking into that. So mobile phone, car parking, when there you can keep it at the car parking. Normally you will keep it at the back tail of your particular car. It can be placed in different places to make sure that no objects are nearby when you're parking them. Sorry. And next is, it is used in industries for counting the number of objects that we will be also looking into, and ground proximity in aircrafts. Okay, how much is it distant from the ground and so on. So we'll be looking into some examples over here. You can see that this particular bottle is moving from the right to the left over here in an industry. Okay, so you can see at the background there's a count of 21. So what is happening when this bottle is moving over here? It passes near this particular sensor over here. What is happening over here? It is detecting this particular object over here. When it detects this, you are programming a microcontroller such that when an object is detected over here, you increment the count by 1. So what is happening when the bottles are moving from right to left, the count keeps on increasing over here, telling you how many of these bottles have been moved on this particular trade. So this is what is happening in this particular simple example over here. Next, you can see this basic example that you use in your day-to-day life. You are using an object to cover this particular sensor over here. What is happening? Your display goes off. When you move it away, the display is on over here. This is just the basic example that you use in your day-to-day life. The practical example of a proximity sensor or IR sensor. And next, we are going to look into what is an infrared sensor, IR sensor. There are two types of infrared sensors, that is the transmittive type and the reflective type. That is, we saw that in the diagram earlier in the first video. There are two types of infrared sensors, the transmissive type and the reflective type. In transmissive type IR sensor, the IR transmitter usually an IR LED, infrared LED is available, and the IR detector usually a photodiode. So an IR LED will be on one side and there will be a photodiode on the other side, a position facing each other, and so when an object passes between them, the sensor detects the particular object accordingly. So IR LED is going to detect this particular light over here, and a photodiode depending upon the particular light falling on it. So you know that IR LED generating heat, photodiode, it is going to receive that particular signal and put the signal over here. So you see that when an object comes over here, the photodiode does not get any signal over here, so no current is passing by. You see over here, it is broken over here, no connection. But when light is falling over here, you can see the difference. That this particular circuit is on, and due to this power supply, it is switching on this particular circuit. So depending on the object over here, the concept is IR LED generating a particular source of light and the photodiode receiving that particular light. If the photodiode is not receiving light, what is happening? The circuit goes off as of now. Okay. When it is receiving light, the circuit is on, conducting. So this is a photodiode. This is the same, almost the same principle of the LDR. Okay. In the LDR, you saw that when light was falling on it, it was conducting, and light is not falling, you saw the thing happening over there. Same principle over here. So next, infrared sensor. The other type of IR sensor is a reflective type sensor. Okay, so what we saw till now was the transmissive type, and now we are looking into the reflective type of sensor. In this, the transmitter and the detector are positioned adjacent to each other. So this is a basic example that you will be normally using in line follower robots and so all these applications. When you see, they will be using these kinds of sensors over there. The infrared reflective type sensor. You have one over here for sending the data and one for receiving back the particular data. Okay, so transmitter and the detector, both the transmitter and the detector are positioned adjacent to each other facing the object. They are both adjacent to each other, and when the object is over here, they are facing the object over here. But here you see that they are positioned in different places. One is a different source and the other one is a different receiver over here. But over here you can see the difference. That is what is happening. When an object comes in front of the sensor, the infrared light from the IR transmitter is reflected from the object and is detected by the IR receiver, and thus it detects the object. Okay, so with the help of infrared light, you can see that one is transmitting the IR signal, and when this IR signal gets hits on a particular target over here and it comes back over here, what is happening? The IR detector over here receives this particular signal, and what is happening? It gives the signal to the microcontroller that an object is available over here. This is the same principle that is also being used in line follower robots. When the signal passes on this, is sent from this particular source and it hits the particular line and it comes back, the robot will be going on the straight line. When there is a particular no tape over there on the line follower robot, if there is no line available over there, what will happen? Okay, the light will not get reflected back over there. When it is not getting reflected back over there, what is understood, you can see that it has to turn up in the direction accordingly. So this is an application that you can use over there, but using a simple sensor, which is a reflective type IR sensor. You'll be looking into them into detail when you study about these IR sensors much more clearly. Okay. So next, similar principle of IR sensor which we saw earlier is the ultrasonic sensor. An ultrasonic sensor is a non-contact type, same as IR sensor, that can be used to measure distance as well as velocity of a particular object. Okay, so it works on the same principle of IR sensor. We'll be looking to that, and its main applications are to find the particular distance and the velocity of a particular object. An ultrasonic sensor works based on the properties of sound waves. Previously, we saw that IR was working on the principle of transmitting and receive IR signals, but here it is working on the principle of sound waves, the one that is used in bats sonar. Okay, we see with frequency greater than that of the human audible range. Okay, so why is it greater than the human audible range? You may keep this ultrasonic sensor near you, and when you're talking in between, that signal should not disturb this particular transmission and receiving. So normally this transmitter and receive signal is in a range that is greater than the particular human audio frequency range, audible range. So, and using the time of flight of the sound wave, the ultrasonic sensor can measure the distance of the object. So, time of flight, how much time it has taken and how much time it is taking back, that hits an object and coming back. So, the time of flight, that is what you call the time of flight. The signal is transmitted and hits an object and comes back. The time taken by that is what you call as the time of flight, and that can be used to measure the distance of the object. So similar principle of sonar that is in bats. Okay. The Doppler shift property of the sound wave is used to measure the velocity. So when you use the formulas of Doppler shift velocity, you will be able to measure the velocity of the object. In what speed is that object moving also. So this is a next level application of an ultrasonic sensor. We'll be looking into basic examples of how ultrasonic sensors are used in laboratory. Okay. Next, this is the example over here. You can see that this is your Arduino microcontroller. It is the same shape of your Arduino Uno. It is connected to your ultrasonic sensor. It is sending a signal, and that signal is sent, hitting the object and coming back. It is sent through one and received by the other. You can see that. Transmitting, hitting the object, receiving. So both are not going to transmit and both of them are not going to receive over here. One is for transmitting and one is for receiving. The time taken over here, as I told you, the flight, time of flight is what we are talking about over here. Okay, and that is used to measure the particular distance. Okay, so and remember you will be using a formula divided by 2. because time you can see over here, it is hitting the object and coming back. So whatever you're going to find is going to be divided by 2, because what if you are not dividing by 2, you are going to measure double the time. You can see that hitting the object, coming back. So whatever formula you're implementing at the end, you will divide that value by 2 to get the actual distance from this ultrasonic sensor and the object. Okay. Next one is a light sensor. It is also known as the photo sensor. We saw this example earlier. Light sensors are one of the important sensors, and a simple LDR is another. It is a simple light sensor is the LDR. Property of LDR is that it measures resistance, which is inversely proportional to the intensity of light. Okay, so inversely proportional to the intensity of light over there. When the intensity of light increases, the resistance decreases over here. So it becomes a good conductor when light is falling on it, and when light is not falling on it, it becomes a conductor. So that is what. By using LDR in a circuit, we can calibrate the changes in its resistance to measure the intensity of light. You can measure how much of light is falling on that particular LDR using the resistance value that you are reading from the microcontroller. There are two other light sensors or photosensors which are often used in complex electronic systems, and they are the photodiode and the phototransistors. Okay, so they are used normally only in complex electronics applications, but the one that is most commonly used is the LDR sensor. All these are analog sensors. We saw that there are two categories of one of the two categories of sensor is the digital and the analog type. This is a type of analog sensor that gives out resistance. I hope you remember. The sensors can give out either voltage or it can give out resistance values. And this is a sensor that gives out resistance value. There are also digital light sensors like the BH1750, TSL2561, etc. And these calculate intensity of light and provide a digital equivalent value. These provide a digital equivalent value and not the analog resistance value. So you can decide on what particular this differentiation or this categorizing of sensors will come into an application when you have an Arduino board with analog pins available or digital pins available, whichever is free. You have a project that is being built, you have only one digital pin that is free, that is available, and you want to use a light sensor. That is when you will be using this digital light sensor. If you have an analog pin that is free in your microcontroller, then that is when you will be using this analog type of microcontroller sensor over here. Okay. So next one is your smoke and gas sensor. It is one of the very useful sensors for safety related applications, that is to detect if there is any smoke or gas in the air. Almost all offices and industries are equipped with these. Okay, so if there is a fire, what will happen? This fire can be detected with the help of this smoke or gas sensor. And immediately you would have seen these in movies or sometimes in real life also. When a smoke is happening from the top, from the ceiling, you will see water spraying down. Okay, so same, yeah, that is the principle. That is the use of this particular smoke and gas sensor. Gas sensors are more common in laboratories, large scale kitchens and industries. Kitchens, the most important place. Beyond a particular unnecessary gas, your LPG gas coming into picture, and that is coming, you have to turn on an alarm and say that there's a gas leakage. So this is a practical example of that used in industries, kitchens, and so on. Smoke sensors can detect smoke as well as gas also. Okay, are installed in homes also. So precaution in homes also. If you are in a remote location, you've gone out somewhere and something is unavoidably and unexpectedly something is burning, then this will give you an indication that something is not good at home, so you can you need to take care of that. This MQ series, we saw that this is coming under this sensor comes under the MQ series of sensors. They are cheap sensors that are used to measure CO2, CH4, alcohol, propane, butane, LPG, etc. So this MQ category of sensors are used for these types of applications. You can use these sensors to build your own smoke sensor application. You just need to connect them to the microcontroller. You need to specify the particular, depending on the gas sensor, you need to specify the range beyond which an alarm should go on. You will connect another buzzer or LED, or you can connect it to a Bluetooth module and send a signal to a remote location saying that there is a smoke or whatever is available. So practical applications are limitless. So I'll see you guys in the next video.